Ever get the feeling that the universe is kind of like whispering secrets to us? What if those like seemingly random numbers in physics are actually clues to a deeper structure, you know?
Yeah.
You sent over some stuff about a fascinating concept, the fine structure constant. It's this fundamental number in physics, and it might be a fingerprint of the universe's beginnings.
Yeah.
We're talking Big Bang, fractals, even electromagnetism.
Right.
Ready to unpack this?
Absolutely, yeah. The fine structure constant, it's denoted by alpha, the Greek letter,
Right.
and the idea that it could have these really profound implications is fascinating.
So let's start basic. What is this fine structure constant? It's about 1 over 137, but it's not just any random number.
Oh, absolutely not. It dictates the strength of the electromagnetic force, one of the 4 fundamental forces of the universe.
Right.
And here's the thing, even the slightest variation in this value changes reality dramatically.
Whoa.
Atoms might not hold together, stars might not ignite, and life as we know it, impossible.
So alpha is like the balancing point for complexity to exist.
Yeah.
It almost makes you wonder if it's designed that way. But maybe that's a conversation for another time. In physics, we usually think of alpha as fixed, a constant, right?
Right.
But what if it's not? These sources suggest something much bolder.
Exactly. What if alpha isn't arbitrary, but a reflection of the universe's birth, the Big Bang?
Okay.
Imprinted on the cosmos during those initial moments, chaotic energy.
Okay, now that's where the fingerprint analogy really comes in.
Yeah.
But how could something like that happen moments after the Big Bang?
Right.
It's incredibly hot, dense, a soup of energy.
Imagine the early universe, like a turbulent ocean of energy, dominated by quantum fluctuations.
Okay.
These are tiny ripples in the fabric of space-time.
Ripples.
Almost like a constant fizz, energy popping in and out of existence.
So these energy ripples could somehow determine a fundamental constant like alpha.
The sources suggest these fluctuations might have had a very particular characteristic, a fractal-like structure.
Interesting.
You know, like a coastline. It maintains that jagged shape, whether you're viewing it from a satellite or under a microscope.
Right.
That's the essence of a fractal, a self-similar pattern repeating at different scales.
So we're saying the early universe was essentially a giant fractal.
Yeah.
And those fluctuations, the ripples in space-time, were arranged in this complex, repeating pattern.
That's the theory. And this fractal imprint, this structure of the early universe, could have influenced the forces that govern its evolution.
So this fractal imprint directly shaped the strength of the electromagnetic force.
Yeah.
And led to the specific value of alpha we see today.
That's the core idea.
Yeah.
It's like the universe was tuned to a frequency, this electromagnetic frequency, based on those initial conditions.
That's a pretty radical concept, that these fundamental constants, the building blocks of reality, might reflect those chaotic beginnings.
It challenges how we see these constants as fixed, unchanging values.
Yeah.
What if they are remnants of a dynamic process? Billions of years ago, a story, a record of the universe's past.
And if alpha, this finely tuned value that governs electromagnetism, is a fingerprint, what else might we uncover by studying it? Could it be a key to understanding the deeper structure of the universe, the forces, the energy that created everything we see?
The sources delve into some really intriguing possibilities, exploring connections between alpha and other fundamental concepts, like waves and ratios.
Waves, like ripples on a pond.
Not quite. Think more like the electromagnetic spectrum.
Okay.
Light, radio waves, X-rays. These are all forms of waves, electromagnetic waves. And guess what? Their interaction with matter. It's influenced by alpha, the fine structure constant.
So alpha governs how light interacts with atoms, how radio waves travel through space, how X-rays penetrate matter.
Exactly. It's like the conductor of the electromagnetic orchestra. And remember, those quantum fluctuations, the ripples in space-time, those can be thought of as waves too.
Oh, hold on. So we've got light waves, waves of energy in the early universe. Are we saying there's a connection?
The sources explore that idea, that alpha might not just influence waves, but it might be a product of them.
Whoa.
They suggest space-time itself could be wave-like, and this underlying pattern, this wave pattern, could influence how fundamental constants manifest, like alpha.
So alpha isn't just a number that governs waves. It's shaped by waves.
Yeah.
Waves within waves. A cosmic echo through reality.
It is a complex idea.
Huh.
But there are these specific numerical explorations in the sources that make this connection even more intriguing. For example, they explore the relationship between alpha and pi.
Pi, the mathematical constant, 3.14159, and so on.
Right.
What does that have to do with the fine structure constant?
Well, pi is intertwined with geometry, circles, and you guessed it, waves.
Okay.
The sources suggest that the difference between pi and a scaled version of alpha could actually be a new constant, undiscovered, revealing a deeper connection between geometry, waves, and those fundamental forces.
So we're talking about a connection between two seemingly unrelated constants, pi, a cornerstone of mathematics, and alpha, this fundamental value from physics. And it could point to a new constant.
It is a lot to process.
Yeah, it is. And the sources don't stop there. They also explore imbalance
Yeah.
and the role it plays in shaping the universe.
Yeah.
And, this reminds me of what you were saying earlier, how even the slightest change in alpha, it would drastically change the universe.
Exactly. It highlights how important these values are.
Right.
The existence of everything. The sources really explore this idea of balance.
Okay.
Or this imbalance as a key to understanding the universe.
I have a note here. You said, and I quote, "Imbalance, dude. If all was the same, we got nothing." It sounds like you're really into this concept.
Well, think about it. The universe thrives on gradients. Differences in energy, temperature, density. Without those, no motion, no change, no evolution.
Yeah.
A universe where everything was the same, it would just be static,
Yeah.
lifeless.
So it's not just that imbalance exists, it's a driving force.
Exactly. Think about the Big Bang. This explosion of energy from a state of unimaginable density.
Yeah.
That initial imbalance set the stage for everything. And the fine structure constant, which was imprinted during those early moments, might be a crucial part of that.
So we've got this web of ideas, alpha, the Big Bang, fractals, waves, and now imbalance. It's like we're piecing together a puzzle, and alpha might be the key. So we've been exploring how the fine structure constant, alpha, might be like a fingerprint from the universe's, chaotic beginnings.
Right.
It's a big change from seeing it as just a fixed number. It's more like an echo
Yeah.
of those early moments. One thing I'm curious about is this idea of alpha as a threshold of complexity. What did you mean by that?
It goes back to how finely tuned the universe is. Remember, even tiny changes to alpha could unravel reality as we know it.
Right.
If alpha was a bit larger, the electromagnetic force would be stronger, and atoms might not hold together the way they do now. Electrons would just be zipping around. You wouldn't have stable molecules.
So a slightly different alpha, and we wouldn't have, the building blocks for anything. Stars, planets, life.
Exactly. It's like alpha sits at this tipping point, this threshold that allows for complexity.
And you're saying that this threshold, the sweet spot for complexity, might be tied to those initial fractal patterns in the early universe.
Yeah, it's a fascinating possibility. If those early fluctuations, those ripples in space-time, if they really did have a fractal structure, then their influence, it could extend beyond those early moments.
It's like the universe's early tune is still playing out in the way galaxies cluster, stars burn, and life emerges. It's all connected back to the beginning.
Yeah. And what's fascinating is that it challenges how we think about the laws of physics.
Okay.
We think of them as fixed, these eternal rules. But what if they're emergent properties of that early state of the universe?
Emergent properties. Can you break that down a bit?
Sure. Think about chess. The rules are fixed, right?
Right.
But the strategies, the complex patterns, those emerge from the pieces interacting, the player's choices.
So the laws of physics are like strategies in chess, emerging from some deeper set of rules that we don't even know yet.
It's a possibility. And the fine structure constant, it might be a clue. If its value reflects that early fractal structure of the universe, then those initial conditions, they could be the foundation from which the laws of physics, emerged.
It's mind-blowing to think about the laws of physics as having a history, a story. We've also been discussing the potential connection between alpha and pi, and that maybe their difference points to a new undiscovered constant. Is that something we could actually test or observe?
It's a very speculative idea.
Yeah.
But it highlights how interconnected things are. Math, physics, cosmology. To actually test it, we'd have to look for phenomena that we can't explain right now with our current understanding of these constants.
So anomalies in the universe, that point to a deeper structure, this new constant.
Precisely. It would require us to rethink our models. But that's how breakthroughs often happen, right? Challenging assumptions, looking for the cracks.
It's like we're searching for a new language, a new way to understand the universe. And this new constant, it could be a key to understanding it. You mentioned earlier that some research suggests alpha might have been different billions of years ago. How do we even investigate that?
Astronomers have been looking at light from incredibly distant objects called quasars.
Okay.
These are incredibly bright objects. They're powered by supermassive black holes.
So we're talking about light that has traveled for billions of years.
Exactly. And by analyzing that ancient light, we can look for these subtle shifts in the wavelengths. And that might indicate different values for alpha in the past.
It's like using light as a time machine, peering back into the universe's history to see if the fundamental constants, if they've always been the same.
Yeah, it's a remarkable feat. And it could change everything, you know. If there's evidence that alpha has changed over time, it would mean the laws of physics themselves, they might not be as fixed as we thought.
That would be a truly groundbreaking discovery, wouldn't it? It would suggest that the universe, it's more dynamic, more mysterious than we ever imagined.
It would challenge us to, rethink our place in the cosmos, to see the universe not as a backdrop, but as an evolving entity, maybe with its own story of growth and change.
We've been on quite the journey with the fine structure constant. It's amazing how one tiny number can bring up these huge questions about the universe.
It is, yeah.
From the Big Bang to fractals to the laws of physics. It seems like alpha connects it all.
It shows how everything's connected. Even the tiniest things have these big implications.
One thing that sticks with me is this idea of imbalance, how it seems woven into the universe itself.
Yeah.
You said, if all was the same, we got nothing. That really hit home. It's so fundamental. Without those differences, those gradients in energy, temperature, density, nothing would happen.
Right.
The universe wouldn't be just boring, it would be completely static, lifeless.
It's like the universe is a giant engine, and imbalance is what keeps it running. And the fine structure constant, this fingerprint from the Big Bang, it could be like a regulator.
The sources definitely point to that. Those initial fractal patterns might have influenced alpha, and alpha governs electromagnetism. So you could say that, in a way, the seeds of imbalance were there at the very beginning.
So it's not just that the universe evolved with imbalance, but that it's built into its very structure.
Exactly. It's a pretty big idea. And it might have clues to some of the biggest mysteries in cosmology, like dark energy, for example, this force that's making the universe expand faster and faster.
Right.
What if that acceleration is driven by an imbalance in the fabric of space-time itself?
And could dark matter, another mystery, be involved in shaping that imbalance? It's definitely possible. We don't know much about these things. But the idea of the universe being fundamentally built on imbalance, it gives us a whole new way to look at them.
Like we're putting together this giant puzzle, and each new piece gives us a clearer picture. This finely tuned alpha, maybe imprinted by fractals from the Big Bang, and these mysteries, dark matter, dark energy, shaping how the universe changes.
And don't forget about entropy, the tendency towards disorder. It's a constant force, right? Counteracting the pockets of order and complexity that pop up.
This has been an incredible deep dive. We've gone from the smallest atoms to the vastness of the cosmos.
Yeah.
And it all started with alpha. It really shows the power of curiosity, how even simple questions can lead to big insights.
Absolutely. And this isn't the end, There's still so much we don't know, so much more to explore. Who knows what else we'll find out about the fine structure constant?
To everyone listening, keep those brains firing. Dive deeper into these ideas, check out the resources we mentioned, and never stop asking questions. You never know what you'll discover.
And remember, the universe is full of incredible things. Keep exploring, keep asking questions, and never lose that sense of awe.
That's a perfect way to end this. Thanks for joining us on this deep dive into the fine structure constant.